The rest of the meeting really is about sustainable pool design. We'll talk about the importance of the pyramid, what we call the pyramid in pool water treatment. We'll talk about turnover rates, about dynamic head, pressure losses in system, how to properly select the pumps. We'll talk about the design when it comes to number of inlets, skimmers, floor drains, and so on.
Exactly. And you will see these are our suggestions coming from our experience. I was 30 years around the world, and each country is a little bit different, but you will get it. Yep. And if you like it, take it. If you say, but not for me, then it's not for you. And then finally, a Q&A. And Q&A, you will see here the green button Q&A. During the presentation, you can send us your question. We will answer it in the end. You also can use the chat, but the chat would be more for suggestion, feedback. This is what we missed, etc. We will really go through the Q&A, but any suggestions on the chat is, of course, very well appreciated.
Yes, exactly. So first, let's talk a few words about Dryden Aqua. Some of you are familiar. This gentleman here in the center that you see is Dr. Howard Dryden. He is a marine biologist with a PhD in filtration. He's the founder of our company, and he is the inventor and developer of AFM-activated filter media. Howard has a wealth of knowledge. He has an incredible combination of knowledge about biology, chemistry, physics.
Yeah, he's the best.
And most of what we're telling you here in these sessions is knowledge that we learned from him.
Yes, and haven't seen it then out in the field. Does it work? Does it or not work? No, this guy, he's really the best. Not really in running a business. There you find betters, I would say. But you know, his knowledge in chemistry. I mean, he's a biologist, but his knowledge in chemistry is unbelievable. I've never seen a better chemist than he is, and he's a very smart guy, very nice guy, and yeah. So what we, you know, our knowledge will come from him. This is the source.
Yeah, absolutely. We have two production facilities, one in Scotland and one now in Switzerland since January of last year. We can produce a total of 50,000 tons. That's our capacity. Last year, we sold roughly 20,000 tons. So we still have a little bit to go, and we definitely have capacity to fill your orders. This year, or last year, I'm sorry, we introduced our latest product, which is our AFM NG, a hydrophobic filter media, giving a 1 micron filtration, which we have seen in Europe is a complete game changer.
Absolutely, it's a game changer. Yeah. And this comes now also to you, to the US, right?
Yes.
And for we invested another, in dollars, that's $5-6 million in our Scottish production, really to bring it on the same level or even higher level than the Swiss factory, you know, where we also will be able to produce this beautiful, perfect AFM-NG in the quality that we have. Yep. So that's great.
Yes. One of our sessions here later, I think it's session 4 or 5, session 5 actually, we will be talking about AFM-NG in detail.
Yep.
You want to take this?
Yeah. Here you see the 3 different industries we are in. So we are not just in pools, you know. Dryden Aqua started really in aquarium and aquaculture, so in big aquariums. Also, you know, in systems for mammals, you know, life support systems for mammals and chlorinated water. And there, Howard has seen, you know, how problematic are these volatile disinfection byproducts, mainly the trichloramine and the THMs. And this is why he developed this Dryden Aqua integrated system, the DAISY system, to really bring this water and air quality to a very high standard. So the dolphins, for example, or the whales get as old in our system as they do in the ocean, or nearly as old. So that's number one. Water treatment. Water treatment is drinking water, it's wastewater, industrial wastewater, it's pre-treatment before RO membrane, so all the desalination plants. This obviously is the biggest, by far the biggest market we are in. We just entered this market, or started to enter this market a few years ago, but we are doing now very big progress on this. And last but not least, it's the pools. Next slide. Yep. The pools. Here you see my twins in a daisy pool. This is how it should like, you know, really good, nice water. And we have in the meantime more than 500,000 pools which are running at least with AFM or Activate or one of our products, not all of them yet with a full Daisy. But pools is quite important for us. I'm coming from the pool industry, and this is why, you know, with our network, and so this was our first logical step.
Absolutely. So being a marine biological company, it was a natural step for us to develop a water treatment system that has a biological approach. And Sean is going to take us through this. I think I have to drive the presentation, right, Sean?
Sure, no problem at all. So yeah, Daisy, Dryden Aqua Integrated System. This differs a lot from the normal course of action in the US, which is to use large amounts of chemicals in the water to try to annihilate any pathogens that are brought in. What we want to do is prevent their ability to propagate, to grow in the pool in a way that produces the least amount of harmful disinfectant byproducts. So step one, of course, with Daisy is our filter media, activated filter media, AFM. It improves the filtration, of course, but it also eliminates the breeding ground on which bacteria and pathogens can grow and multiply. That's biofilm. We eliminate biofilm growth in the filter. Step two is APF, which is a multi-spectrum coagulant and flocculant. It's the only one in the industry. And what this allows us to do is to pull things out of the water, out of solution or suspension that filtration normally won't be able to pull out. Beyond that, we're also removing all of the nutrients that bacteria need and algae need to grow in the pool. So it's 5 different active ingredients, and it's a multi-step process. Mm-hmm. And finally, for outdoor pools and pools with UV systems, we have ACO, which this protects chlorine from the sun, but not like cyanuric acid does. This is a replacement for cyanuric acid. So first step is we protect the chlorine from UV light. Second step is that reaction is a catalyst for producing additional oxidants in the water.
Okay, summary.
Yep. So again, this can be used with all types of pool water treatment, and the results are the absolute best filtration available in the industry, possibly down to 0.1 microns when you use proper filters and flow rates. Oxidation demand is therefore reduced by up to 80%. Your chlorine is going to have a much easier job of disinfecting the pool. If we're using less chlorine, of course, we're going to produce less of the toxic disinfection byproducts that chlorine produces, such as trichloramines and trihalomethanes like chloroform. And of course, you know, to summarize what we stand for as a company is the safest and clearest water possible, the best air quality for indoor pools, and the lowest possible chemical consumption and operating costs. So you spend a little bit more upfront on the Daisy system and properly sized filters, and in the long run, you save yourself a lot of time, money, and headache.
Well done. Good.
Very good. Thank you, Sean. So
sure.
There is an entire session, I believe it's session number 5, to take you through this Daisy system, everything you need to know about Daisy.
Session number 5 is just AFM. Session number 6 and
then.
all the Daisy.
You're correct.
And, but you will see, it will be really interesting.
Yep.
So join us on each and every session.
Great.
Yep.
Next topic, I mentioned the pyramid of pool water treatment. You notice here, this is a pyramid. Obviously, it's really upside down. And it's upside down because, unfortunately, this is one of the realities that we see outside, that there is not enough focus and concentration on filtration and hydraulics. And because this is not sufficient, then all the focus needs to go on treating the water and dealing with the biology and the microorganisms that develop in the water.
Yeah. I don't know in the US, but you see it very often in Africa. You see it in Asia, very small filters. But then in the pool, to compensate for it, high levels of chlorine, 3 ppm, 5 ppm, where we can run our system with 0.23 pm. So and we don't want this situation. We want to have a different one.
And you know, part of the reason why we see this, you know, is because of this here. You know, a client, a pool owner, a future pool owner wants to have a pool built. Of course, he wants a state-of-the-art with all the bells and whistles. The pool builder makes a quote. The client comes back and says, this is way over budget, and asks for savings. And then what does the pool builder do ultimately, or the installer? He compromises and cuts corners. He reduces pipe size, he reduces filter sizes, he buys cheaper pumps. He doesn't use AFM, but a cheaper media, for example. This is not sustainable. And this really leads to a number of problems. One is the performance of the pool is not satisfactory. You have your water and air quality is not what the customer is expecting.
Yeah.
It's shit.
Yes. Yeah.
And,
sorry for my English.
Yeah. And ultimately, there's a lot of costs that are being developed to fix things later in the progress.
Yeah, also
right?
the running costs are higher because you need more
absolutely.
chlorine, etc. And to fix it, very often it's impossible, you know, especially hydraulics, it's not possible anymore. So we want to give you the good arguments that at that point, you talk to the customer and say, listen, gentlemen, I would invest here $200 more, get this filter a little bit bigger with this and this effect you will have. It's worth to invest it. And not everybody will follow, but if you bring the good arguments, people will understand that. They will take you seriously. They will take you as a pool expert. And that's what we are doing.
Yeah, exactly. So when we talk about pool water treatment, there are really 4 steps that we need to consider. The first one is pool hydraulics, because with properly dimensioned pool hydraulic, we will reduce energy losses, we will ensure proper filtration and proper backwash.
But also, you know, with this, it's very important that we mix the water well, that we avoid dead zones. And this is what we will, especially in this session, go very much into detail to see how you do it, that you have a good mixing. If you don't have such a good mixing, what can you do? Yeah.
What can you do to improve it also? Exactly.
Talking
Then the second
cleaners.
step is about filtration and flocculation.
That's our heart.
That is our heart, right? So the more organics you can remove from a system, the less oxidation demand the water has. If you use less chemicals, less chlorine, less oxidants, then subsequently you have less toxic and harmful disinfection byproducts.
Yeah, it's quite a logic relation. If chlorine consumption goes down, disinfection products go down.
Exactly. Yeah. Fresh water?
Yeah, if you do a very good filtration, then you also can sometimes save a little bit of fresh water, have shorter or less quick backwash velocities. That's not our main focus. Our main focus is to bring the best water quality, but very often we also can do some savings on this. Definitely we'll have savings on the chemicals, on the oxidation. If we reduce the oxidation demand by 50% or even by 80%, use 80% less of chlorine. You know, that if a big public pools, you know, instead of using 20 IBCs, only 10 IBCs, that makes a difference. That makes a difference in dollars, but it also makes a difference for the environment, in transport, in production. But our main focus is the last point, you know, and this is not, the first point is to reduce operating and cost and environmental impact. Sorry for this. But the main point is optimal bather comfort and safety. So really to minimize the disinfection byproducts. Actually, what we are doing with the dolphins, we want to do with your customers. Keep them safe and healthy.
So session number 4 will be about biology in filters and disinfection byproducts. So we will talk in detail.
Yeah, and they will come back in. They are a little bit interlinked. Best is you follow all of them. Then you have
absolutely. So the summary of this is get the pyramid right. And to get the pyramid right, the focus needs to be on filtration, flocculation, proper hydraulics, proper backwashing.
Yes,
this is the foundation.
A good base.
Yeah.
And then
all the rest will come automatically in a way.
Yeah. And this is, if you go for the next one and the next one, you know, this is how we want filtration and hydraulics first to make a proper stable base. and not the other one, you know, where chemicals come first, where you'd have to focus on this, and you have a very unstable situation.
Yeah. Okay.
Yep.
Next topic we want to bring up here is turnover rates in public and private pools. Sean, you want to say a few words about this?
Absolutely.
Great.
So load and water temperature are key, obviously, for designing a pool with a proper turnover rate. And the reason for that is bacterial growth occurs very rapidly the higher the load, and especially the higher the temperature of the water. So if we have a small pool or a hot tub, we have to increase the circulation in order to be able to turn over that water more often, remove bacteria and pathogens and contaminants and debris with the filtration in order to compensate for the load. Likewise, the warmer the temperature, the higher the circulation rate must be. And we see this in the Model Aquatic Health Code. For hot tubs, the hotter it is and the more bodies that are in the water, the more we have to turn over that water to keep it safe.
Yep. So Dominic, you brought a good example today. You know, if you have 5 people jumping in a pool with 10,000 gallon, or you have the same 5 people jumping in a pool with 100,000 gallon, the load on the water is 10 times less, right?
That's exactly what
this
it
is. Why
yeah.
this is why what Sean says, size of the pool, obviously, and beta load have a big impact. In addition to that, water temperature as well. Anything you want to say about bacterial growth?
Sure. This is a good example of how temperature affects bacterial growth at 68 degrees. After 10 hours, we'll have 16 pieces of bacteria, 16 individual bacterium. And when you go to 77 degrees, the same 10 hours, we're producing 256. And at 86 degrees, that number is 500,000. So temperature makes a huge difference. And, of course, moving water is going to have less biological growth. It just, because of the flow and circulation and turbulence, bacteria have a much harder time growing, mainly because they're not able to attach to a surface very easily and grow the biofilm that they do, and that is needed for rapid biological growth. So obviously filtration is always recommended in public and private pools. We can turn the water over as much as we want to, but if we're not pulling the debris and the pathogens out of the water, it's only maybe 10% of the equation circulation is.
Mm-hmm.
Let me add one thing, and I try to do it in Fahrenheit. So, in this example, you see 86 Fahrenheit height. The doubling rate of bacteria, of heterotrophs bacteria, if there is enough food, is 30 minutes. If you go to then more to 88, 98.
98, yeah.
Oh,
over
yeah,
here.
yeah. Okay, 98. It's only 50 minutes. So if you increase this by 10 Fahrenheit height, you halve the doubling rate. And same goes if you go down. So at 68 Fahrenheit height, doubling time is every 2 hours. And you see what big impact this makes. And that also explains if you have really cold water, like 5 degrees, what would that be in Fahrenheit height?
Maybe 42.
40, 50, at that temperature, the bacterial growth is nearly 0. Yeah. Then you don't need any disinfection then, because it's too cold for them. Yep.
That's why you don't need much chlorine in the winter when your pool's closed anyway.
Actually, you don't need any. Just make a little bit of circulation. Yes.
Yeah.
Okay, that was moving water is safe water. That goes back to you, Sean.
Yep. Yeah. So, if you had a choice of where you were going to dip your water bottle into a body of water on a hike, you'd probably choose the pool on the right. With the flowing water, this is common knowledge that flowing water is safer to drink.
Absolutely. Where would you rather drink from, right? Yeah. Follow your instincts.
So another interesting topic is filtration and what happens when you stop filtration. Obviously you're not moving water, you're not filtering the water anymore, but something biological takes place as well. The heterotrophic bacteria that we've collected in the pool will eat the food and consume oxygen. Eventually, there won't be any oxygen left, and the bed becomes anaerobic. And at that
if you
point,
stop the filter, if you stop,
yeah, if you stop the filter, if
Right.
we stop filtration, you know, whether that's through stopping circulation or just completely cutting the filter off and just circulating the water, these heterotrophic bacteria are, again, they're going to deplete the oxygen in the system. At that point, the nasty stuff comes in, anaerobic bacteria. This is smelly bacteria. Most of it's pathogenic. It's not something you want in your pool filter. So in order to fix that, you know, in commercial pools, most of the time we're running 24 hours a day anyway. But a lot of times in residential pools in the US that are stuck with 1-speed pumps, they're going to run 6, 8, 12 hours a day and shut them off. This is highly detrimental to the system overall and really unsafe in the long run. So what we can do is use a 2-speed or even better, a variable speed pump, run it 24 hours a day on a lower speed and eliminate that possibility of anaerobic bacteria taking hold in the filter and the plumbing.
Exactly. Let me stress this once again, you know, that you fully understand. You know, it has nothing to do now with AFM, even with a sound filter. It would be good if you're in 24 hours filtration. And if you say, Dominic, I don't have the budget for this, you know, this cost of electricity, even if you go through your filter with a very low numbers, like 1 cubic meters per hour, that would be a very low amount, you know, a tenth that you usually would do, you never get anaerobic. Your power consumption is 0 or near to 0, but you never get anaerobic. And it's good if you never get anaerobic. So learning number 1 for today, try to stay really in 24 hours filtration. Never stop the filter. If you stop it for half an hour, nothing happens, but not for 10 hours. That's not good. And especially in public pools, they should be definitely in 24 hours mode.
Mm-hmm.
And you know, I think if you cut your filtration velocity in half, you're saving 75% of your energy, right?
Absolutely, yeah. So that's because the resistance in the system goes down by a factor of 4, and this is why your consumption comes down. And if you cut it again by half, then it's another 75. So that's what I mean. You know, even with 50 watts, you know, you still turn some water and you never get anaerobic.
Exactly.
Yeah.
Okay, so here we have some examples, some general rules for turnover rates, right, Sean?
Yep, definitely. For private pools, residential pools, we're saying we'd like to see every 4 to 6 hours for turnover. And by turnover, we mean circulating the same amount of gallons of water that exists in the pool. So this also is highly dependent on load and temperature. If we're running a very warm pool, we want more turnover. If the pool's cooler or not being used, we can run slightly longer turnover rates. But we want to see 3 to 4 cycles per day minimum. And some suggestions for a small 15,000 gallon pool, a 4-hour turnover rate for 8 hours is going to give us 2 turnovers in that time period. And then at night, we can slow that down a little bit to an 8-hour turnover rate during 16 hours. So for 8 hours, we're going to run it on a higher speed, get 2 cycles, and then lower that speed down for the evening is what we would recommend and achieve 2 cycles. So that's 4 turnovers in the day. But even more important than that is, you know, some examples of filtration velocity. 12 gallons per minute per square foot for the 4-hour turnover rate. We're able to increase that, or I guess decrease the velocity, but increase filtration performance to 6 to 8 gallons per minute per square foot of filtration area. That recovery period is going to work wonders for the pool from a clarity standpoint, but also from a chemical consumption standpoint, because we're able to filter out more pathogens. For a larger pool, go ahead.
And the filtration velocity, you decide with what size of filters you do. This is in session number 2. Today, we just say, what should be your pump? What should be your turnover rate? And that's our recommendation. And actually, if you say, well, 12 gallon per minute per square feet, that's too low for me, then you take 18 and you reduce it down to 9 during nighttime. You still have this. By the way, can I quickly have this? You know, if in this example, you know, here you would have probably 600 watts of power consumption. Here you will have 150 watts. So you see how much that drops. Also, one thing that I think it's worth to add, you know, if you have these 4-hour turnover rates, that means not that each and every drop of water or liter of water which is in your pool have seen your filter to take the solids out and are disinfected. It's only about 60%, you know, because, and this depends very much on your hydraulic system. It will take 4 times longer, up to 16 hours, until each and every gallon have seen your filter. Yeah.
Yeah. Maybe one word here to add about filtration velocity. You see here 12 gallon per minute per square foot. Filtration velocity is always a water volume over a filtration area. This is, by the way, this is an equivalent to 30 meters per hour.
Yeah,
this is what we recommend at Dryden Aqua. We understand that, Sean, right? You know, NSA 50, most filters at NSA 50 rated are a 20 gallon per minute maximum filtration velocity. At that, you can operate it at that velocity, but your filtration is going to be lousy. And this is why most of the commercial industry has been moving to 15 gallons and even 12 gallons per minute now per square foot, because that is the right maximum filtration velocity.
Yeah, and honestly, you know, to filter, you know, not so, I think 20 inches compared to, let's say, 30 inches.
Yeah.
There's not so, I mean, we're not talking about
Maybe
thousands and thousands of dollars, you know, we're talking about small amount of money.
Yeah.
Right.
Cost difference,
Yeah.
Absolutely.
But we talk about this more in detail.
And then, of course, right, John, when it comes to commercial pools, you're a bit closer to the rules and regulation. Obviously, we have codes that we need to follow. You put this together here to show us what I think that's the MAC, right? The Model Aquatic Health Code.
This is right out of the Model Aquatic Health Code for different types of pools and the turnover rates that they recommend. For example, you know, an interactive water play or an activity pool, or a wading pool, for example, these are pools where we're going to consider low volumes of water. They're very shallow or even splash pads. They're going to need very high turnover rates because the bather load to gallons of water is extremely high. So half an hour or less for an interactive water play. You know, the MAC recommends all other pools, which would be, for example, like a lap pool or a competition pool, be it 6 hours or less. We recommend 4 hours or less. You know, the more the better. Obviously, we don't want to start ramming a bunch of water through our filters and decrease the filtration performance too much. But, you know, if we have the opportunity to design a pool, we want to see 4-hour turnover rates in all pools, maximum 4-hour turnovers.
Yeah, but I think these numbers make a lot of sense. They're quite near. Just the red one, not all other pools is near more 4 hours. But
this one is interesting here for spas. This, you know, for very hot water, this is in Europe or German DIN is 4.5 minutes.
Yeah, let's say 5 minutes.
5 minutes, and here is 30 minutes, right? Yeah. So this is a big difference. Obviously.
There's a big difference, I think this is a little bit high.
But other than that, I think
the 5 is a little bit very sportive in the German DIN, but anything, let's say like 10 or 15 minutes, I would not go higher than this. Yeah.
Okay, excellent. So next topic is, now that we have talked about turnover rates, we've talked about calculating your filtration and backwash volumes. The next logic step is now to talk about pumps, right? And how to select the right pump. We have a little example here that we want to take you through that shows the dynamic head of an overflow pool. And, you know, we have these 3 heads basically that you will find in a system like this. The first one is the geostatic head here, or the elevation head. In this example, this is approximately 10 feet, which is an equivalent to about 5 PSI. Then you see the balance tank here. for this overflow pool. We are sucking water with the pump here from the balance tank. This is an average number of 2 psi that we're calculating with. We now run the water through the filter. We have a pressure head in the filter that we need to overcome.
The pipeline as well.
And in the pipeline as well, exactly. So we calculate in this example 7 psi. Now the water goes back into the pool. On the way to the pool, it may have to go through a loop, a bypass, a UV or a heater or whatever. So we're going to lose more friction head here, more friction head on the way to the pool. And then last but not least, again, we're losing head here in the jets, right? The jets, based on how they are dimensioned, will lead to some pressure loss. So in total, you know, for this example, we are looking at about 22 psi of dynamic head, which is an equivalent of about 50 head, about 50 feet of head.
Question.
Yeah.
This is now an overflow pool.
Yes.
How would that look like if you would have a skimmer pool? And you understood, you know, this geostatic height, this is the water level from the balance tank to the water level from the pool. So if this is 1 meter, this geostatic height, you tell it then in feet. Huh?
Yeah, it's okay. 3.3 feet is 1 meter. So.
Oh, okay. Yeah. It's not that complicated. Okay. This is what you have to understand. So this is the difference from this water level from the balance tank to the water level to the pools. Now in skimmer pools, how would that look like?
In a skimmer pool, assuming that the skimmer is at the same level as the water, right? In a skimmer pool, you do not have this geostatic height to push the water back into the pool. So subsequently, your filtration head loss would be 5 psi less. So you look at about 17 psi of head loss. Okay. Question for you, Dominic.
Sure.
If we look at the backwash loop.
Yeah.
Now here's the pump. We're sucking from the balance tank. Why do we have more pressure here? It's the same distance, the same pipe, but why more pressure loss?
So you're talking about in the backwash. In the backwash, we have more volume, right? We have in filtration, we have 50 gallons per minute. And to backwash the filters, we need 75 gallons per minute. That means the speed in the pipe is a lot faster. Yeah. And therefore, you have more resistance. And that makes a difference from the 2 to the 3 psi. Yeah. And the same goes, you know, if you go to the 10 psi in the filter of pipework and the filters, so the 10 to the 7, this is just because you have a higher velocity. You're with 75 gallons per minute instead of 50 gallons per minute. And the higher the velocity, the higher are the pressure losses.
Yeah. Yeah. That was the right answer.
Good.
Yeah.
I'm happy.
Good.
I passed.
Okay, so now we move on to the pump curves. You know, based on what we just found out, we have a flow of 50 gallons per minute. We have a head loss of 22 or 50 feet of head. We take a pump curve. We go to the gallons that we need for the flow. We find this pump curve here. This is a pump curve. This is a product called Spec. A single, what is it called?
Single speed.
Single speed, thank you very much. This will give us, or this can overcome a head of roughly 50. So good, right? This would be the right pump for the filtration. Now, if we look at the backwash, on backwash, we would need 75 gallons per minute, right? We need a higher velocity to backwash and lift the filter bed. So we need more, we have a higher flow, which is 75 and not 50. And if we use the same pump, this would give us, you know, would allow a maximum head loss of 40. In our example, the head loss was only 30, so we're okay, right? But really, we might have to either throttle it down or we have a higher backwash velocity. That could be a problem. The solution, a much better solution, a much more, you know, 21st century solution is to use a variable speed or frequency controlled pump.
Absolutely.
Right? And this is the picture that you see. This is one pump that can give you all these curves. right? And everything that is basically the whole area here below this curve here are points that we can go to. You can pick any point in here, and you can program your pump so it will deliver the amount of water that you need at the resistance that you have in the system.
Yeah, and as you said, it's 21st century technology. I mean, we should use this. This is a no-brainer from many points. You know, if you have a single speed, you always have the maximum power consumption, and you just have then to frame it down. So you're wasting energy, you're wasting the dollar of your customer. It's better he invests this first, you know, in a variable speed pump, and then you get to the right point. And of course, also together with this, for me, you know, a flow meter is a must, because this is how you can control it.
Yeah.
But then you're safe, then you don't have to calculate. You just look on your flow meter. Yes, this is the speed I want. And then you're spot on. And yeah, that's how you do it.
Yep.
And that's in Europe, that's in America, that's in Asia, everywhere.
It helps save energy, and also it comes with all these benefits, of course. So in summary, if we look at what types of or the total heads that we're looking at, usually these are rules of thumbs that help with the calculation. In public pools, we're usually looking at about 22 psi in filtration for head loss, and about 15 psi in backwash mode.
If you follow our recommendations on the velocities in the pipe that we cover in session number 3.
Yep, exactly. And if we look at private pools, we have skimmer pools and overflow pools. Skimmer pools will be in the area of 15 to 18, backwash 9 to 13, depending on whether your filter is at the same water level or actually below. So it has to overcome the static head that we were talking about a couple of minutes ago. And for overflow pools, this is what this picture looks like.
Make one click more.
Yep.
Oh. And if you use, again, variable speed pumps together with a flow meter, you don't have to make a headache. Just take your VSD pump big enough. It's never too big. And then you always can go down to the right point, and you will have, you also have another, you know, if you go down then with the velocity, you also have much less noise. You have less of power consumption, you have less of noise.
Yep.
This is how you do pools today.
Yep. Exactly. So another topic we want to talk about with you today for a few minutes is the pumping efficiency and the equal distribution, right? This is what we call the Staghorn distribution to ensure equal pipe length. And this is what we mean here. So this is an example where we have 2 nozzles that we come in here with 2 pipes that have the same length. So the pressure distribution is equal. This is how we would design it with 3 nozzles, 4 and 5.
And so on.
And so on. This can be used on the suction side. It can be used on the pressure side. There's really no difference. Another option is to use a large collector. Here we would
go for the next one, then you can explain it better.
Okay.
Or maybe first here, you know, to explain, you know, what is wrong here. You know, let's assume you have this distribution. You come here with your flow, quite a high speed, 2 meters per second or higher, and then a lot of the water will go through the first nozzle, much less through the second, and through the third, nearly nothing. And the same, of course, on this side. So here you have a good mixing of the water, but here you have dead zones. You have the pond that Sean refuses to drink out of it. So this is what we do not want. And this is why you do this Staghorn pipe distribution.
Yeah.
What you also could do, what Philip said, if you oversize this, that means, for example, instead of 1.5 inch, you do this 3 inch. Then you have a very low velocity, and then you also have an equal distribution. We call this a collector. And I think it's the same in US, right? So these are the two things. What we do not want here the dead zones. And this is why you really have to make sure you have an equal distribution.
So the next slide shows how it is done correct.
Yeah.
Huh? So here we have, thank you. Here
we have, I'm only your assistant.
Here we have the Staghorn distribution. allowing an equal flow here. Also on the opposite side, we have a staghorn approach, and also for the collector down here, huh?
Yep.
Very simple, straightforward, but this is how you get your pressure distribution right. So here's a good overview for skimmer pools. And, you know, if you look at some of the sizes here, they come from the metric conversion, but you will recognize some of these sizes. One pool, for example, you know, and we want to look at the volume. That's more important even. These are very common, you know, 15,000 gallon, 30,000 gallon. These are two residential pool sizes that are quite common. If we look at this one here, then we would have a filtration of 53 gallon per minute, right?
So here we took not 4 hours and not 6 hours, we took the medium.
We took the 5 hours. And we filter at our recommended filtration velocity of 12 gallon per minute per square foot of media. So if we do this and divide it by 7, then you will get your 12 roughly. So in order to pump this much water through your filter at 12 gallon, you will need a filter of that size, of that 7 square feet. Huh? This is actually calculated at 8 gallon. I see this here. This is 20 meters per hour.
Oh, okay. You're sportive.
This is 20 meters.
I haven't done it.
Yeah, okay.
I haven't done it.
I need to double check that. But this is how it's calculated. So a skimmer of a pool of this size, we would use usually 2 skimmers. Huh? This is the rule here, 1 per 325 square feet.
300 maybe, make it simple, 300 square feet,
And we would use, normally would use 4 nozzles, 4 inlets.
No, that's wrong. In Germany, they use sometimes only 4. We in Dryden or also here in Switzerland, we would go for 7.
We would go for 7, right? And 1 floor drain. Why would we go for 7?
To have a better mixing. And
can we see it here?
You can.
Yeah, I think we can see it here.
You know what they usually would do now in Germany. I understand also here in Switzerland. You know, they make it very simple. They have 2 inlets on a high level. You know, maybe 10 centimeters below the water surface, where they just push the water over to the skimmer.
Yeah.
So the skimmer we would have here, usually in the direction where the wind goes. Also where we have the pool cover. I don't know if pool covers is something that you use a lot in America. Here we have it in nearly every pool. So if you unroll the cover, then of course you end up here with the dirt, and the dirt just jumps into the skimmer. So usually they are doing this here, you know, that they have here 2 inlets, maybe 1 in the cover niche, and that's it. In Dryden, we recommend to add some more inlets. Mainly, this is a little bit high, you know, just 20 centimeters above the bottom to create a water roll like this, and then to create a skimming to the skimmer. So you would have in your example 2 skimmers.
So you move the surface of the water towards the skimmer, and then below you use jets to roll the water.
But listen, I mean, you talk with 10 people about hydraulics, you have 10 solutions. The good thing is you have to mix the water. You have to mix the water, you have to avoid dead zones. Here you see a dolphin from Matronics.
So our friends from Matronics. So why did we add this here? You know, to impress them?
Yes.
And not only.
And you know, these cleaners, they're fantastic. They clean the floor, but even more important for us, they mix the water. Even if you have a shitty hydraulic, you know, if you let run your robot quite often, you mix the water. It's 15, 20 cubic meters per hour. So it's a very good mixing, and it really helps. So if you have a perfect hydraulic, the mixing is not that important. But if you have not such a perfect hydraulic, use often your cleaner. Even if your pool is the floor is not that dirty.
Yeah, it moves. It moves a lot of water.
Take back
for sure.
I
take back the control. So this is the last slide about this topic here, and this is really to show you how to dimension bottom nozzles. You know, average, we recommend 1 nozzle per 60 to 80 square feet, depending on the water depth that we have. It's either 60 or 80. This will allow, again, an equal distribution, a good flow.
Yeah, you want to cover all the surface, and that's why the deeper the pool, the less inlets you need. The more shallow the pool, the more inlets you need. That you cover really the full surface, and that this surface then can overflow in your overflow pool. And of course, overflow pool, I mean, first, they look much nicer than skimmer pools. You know, in a skimmer pools, you swim like this. In an overflow pools, you're on the top. That's why I think it's also called top level pool or whatever. But also from a hydraulic point of view, you know, in skimmers, you have 2 or 3 skimmers where you suck the water in this, what is this, 1 feet. If you have an overflow pool, it's, you know, you skim all around your pool. So that makes a difference. If you can, if your customer can afford an overflow pool.
Okay, question. Would you want to sit in an airplane knowing that your pilot flies blind or without instruments? I think the answer is no, right? Well, most of us don't fly that often anymore, but that's another subject, right? At least we are not. But anyway,
I'm missing it.
We are, I think you understand now after this presentation, the importance of a flow meter. Whether it's a flow vis or not, that's a different question. This is the best flow meter that we know, that we also distribute, and it's very important to properly use it. Why is it important? It gives us security on our process control. We know the backwash velocities. We know the filtration velocities exactly. This is an example here. You know, if you use variable speed pumps, you can set it accurately. So you have a lower filtration at night. You have your regular filtration velocity here, and you have your backwash velocity. You know exactly where you are.
Yeah, you called it the recovery mode, right?
Yes, I've also heard that that term. Yes, exactly.
No, but this is how you have to do it, and especially if you have variable speed pump. I just mentioned before, you know, this is 21st century, so it's not acceptable not to use them. Okay, I'm a little bit black and white, but especially if you have them, then you need a flow vis, because that really allows you to go exactly where you want. And if you just make this from your feeling, I promise you, you will be wrong.
You will be wrong.
You will be wrong. And you will have a lot of savings because...
and you have a good example towards the end.
Yeah, that's
flow vis example where...
Yeah, but I'm talking now just about the savings. You know, if I run in the day mode and I go into recovery mode, which is half of it, you think, well, instead of 2,400 RPM, I go to 2,000. In the reality, you can go down to 1,600. And that's another saving of 200 watts. But these 200 watts multiplied with 10 hours, multiplied with 360 days, that makes, I mean, you pay the flow vis in 6 months.
Yeah, that's your payback. So a couple of important features that are also reasons why we like the flow vis. One is it's a very innovative product, also functioning as a return, a non-return valve, at least for the 2 smaller diameters.
1.5 and 2 inch, yes.
Exactly. Plus, and I think that's for sure the biggest,
that's the key one.
Biggest advantage here is that it can be installed anywhere. You know,
it's idiot-proof. You can't do it wrong. And don't ask me why, but I like idiot-proof products. You know, in a normal flow meter, you have to do 10 times the diameter of the pipe on each side, straight line. If you don't do this, you know, your results will be wrong. And here you don't need it. You install it upside down just after 90 degrees. You have a perfect reading.
In addition to that, you also have a very clear, a very stable reading. No jumping. You have no paddle wheels, no floats. It will not stick and bounce. That's what we've observed now with how many units have we sold since we introduced it? 10,000,
15,000. A good number.
So a good number, absolutely. And of course, the product is NSF 50 certified. We have it also in the US. It is also available for mostly commercial applications. I would guess here together with a digital display that we are just introducing now. Has a number of features here. It shows the turnover rates, the graphical, the flow rates, digital readout. Very well made product. This is what we have available. Sean, anything to add from your side?
No, we were keeping all of the FlowViz valves in stock, or at least immediately available for order in the US. Contact me for pricing.
Yeah, exactly. So that's what we agreed. We are the exclusive distributors here in Europe. We are not exclusive in the US, but because we have very high volume, we also get very good pricing.
But
so
honestly, if you buy them from us or not, I don't care. But buy them, install them in each and every pool. It gives you and us so much more knowledge, so much more of process control.
Yeah, especially, you know, we don't see them on residential pools much at all in the US.
Not yet. This is why we do this seminar. This is the learning from this lesson.
Yeah, they're key, and it's such an inexpensive investment to know what's going on with your pool.
Exactly.
Yeah, a flow is for every pool.
Yeah. Good. Last point here to mention about FlowViz is very low pressure loss. You know, for the big diameters here, we're talking, you know, very low head losses. You can see these in these curves here. So
a little bit higher for the small ones, but still.
Do we have anything to add? Those are your two slides. This was your project.
Okay.
Well, this was actually the pool that you learned to swim, right?
Exactly. Yeah. So this pool is more than 20 years old. Actually, it's more than 60 years old. Here, this is our Manfred. You know, he changed the filtration with new filters, backwash valves, spec pumps, and flowies. And when he went into commissioning, he called me and said, Dominic, this shitty FlowViz is not working. It's not showing a number. You know, it's always on very low. And I came there and had a look, and he backwashed the filters, and the bed was not moving. So I said, Monty, I think we made a mistake. It's not this. And this is another learning. You know, flowies are the opposite of man. They are not lying. All the women will understand what I mean. They are not lying. They tell the truth. So if you find out there is no flow, it's not that the FlowViz is not working. It's something wrong in your system. And this was here the case. You know, then we went back. We thought, well, to backwash the filters, I keep this now with cubic meters per hour. Don't go into details. You know, we thought we have a resistance here. And that would have allowed us a good backwash with this blue curve pump. But obviously, the FlowViz told us no. Instead of getting 50 or 60, we only get to 25. So we went back and had a look on the system and said, okay, yeah, you're right. We only have 4 aspirations, 2-inch. We have a CPM in DN100. We have quite a lot of elbows. So we had more resistant that we planned. We planned, really. And so we changed the pump to the orange curve, and then all worked well. These we learned on the commissioning, not 2 weeks later when you start to get problems, or 2 months later where you get really in troubles and pathogens and whatever. You've learned it in the first minute. And this is really the value of this FlowViz. So again, if you have one learning, it is a FlowViz in each pool.
Okay, clear message.
Yeah.
Thank you, Dominic. So we are at the end of session 1.
And we want to motivate you. It's like in Netflix, you know, for session number 2. So in session number 2, we will talk really about filtration and backwash. We will give you an overview of different types of filters and filter medias. We will explain also the difference between activated carbon and anthracite, and when you use what and in which configuration. We will talk about filter hydraulics, what difference this can make. We will talk about the backwash and filtration velocities. For how do you see this in performance and how you calculate this? And last but not least, how to properly backwash sand filters. So it's